Welcome, Minds and Machines students, to Lesson 2.03, the Engineering Design Process Advanced. To begin with, we're going to cover why there are actually alternative models for the engineering design process and discuss a couple of them. And then we'll go a little bit deeper into the one that I am going to want you to use this semester as my advanced students, and that is the engineering design process I'm going to outline, which has steps of researching, prototyping, testing and evaluation, iteration, and communication, which we'll dive a little bit deeper into. And today, just starting off with researching, because in a few weeks you all will begin to select your projects and begin working on them, and so it will be very important for you to know how to actually begin researching the problem in order to get an A in this class. Let's begin. So there are actually alternative engineering design process models. The one that I discussed in the basic lesson is the one that is encouraged for use in Volusia County schools, is the Volusia STEM engineering design process, which they use a model called the 5 E's. Those 5 E's, as discussed, include engage, explore, explain, elaborate, and evaluate. This is just one way of looking at the engineering design process, however, even though the kind of underlying steps of thinking about the problem, exploring possible solutions, developing possible solutions, further developing those solutions based on what you learned and testing them out, and then communicating your results to others, those kind of steps are shared amongst all of the models. I personally don't really like the Volusia STEM EDP as much, though, because you don't really know what you're supposed to do with, for example, the word engage. What does it mean to engage with something? Well, it could be to develop a solution, but you would be skipping ahead a few steps in there. So I'm going to present to you a few different models and then really explain the one that I've been using the past few years and one that is used in industry. So there's another engineering design process model, one that's commonly used by NASA in their K through 12 STEM outreach programs, and that is ask questions about the problem, imagine possible solutions, plan out what you're going to do, create something, and then improve upon it. And this is a great model as well. And then another one that with an organization that you may be familiar with, Project Lead the Way. Some of you may have participated in some of their programs. Their model is to define the problem, plan out a solution, develop a model, test that model out, and reflect. And hopefully, you're starting to see kind of how these words, how these steps are pretty similar. And then the process that I'm going to ask you to use as my advanced students for Minds and Machines is an engineering design process with the steps researching, prototyping, testing and evaluation, iteration, which means going back and doing this over and over, and communication. And why I use these terms is because those are the terms that are actually used in industry and at businesses, in government, the terms that are actually used at NASA when doing the engineering design process. And I believe that you all can handle actually knowing the kind of bigger words associated with the engineering design process without having to kind of scale it back as much as these other models do. So, but again, it's the same kind of steps, the same information where you think about the problem and possible solutions, you develop something, you test it, evaluate it, you go back, you rebuild, retest, reevaluate, and then you talk about your results with others. And just like with the Volusia STEM engineering design process, those 5 E's, where you always go back and you restart the cycle every time you finish and you re engage with the problem, re explore. After you improve your design in the NASA model, you go back and ask a new question and reimagine things. Project Lead the Way. After you reflect, you redefine a new problem, you plan it out, and you model it. Same thing here with after you communicate your results with others, you go back to researching and then prototyping something new. Visually, this is how it looks, except for maybe I should have added a new arrow, which, I'll do that right now actually. Because iteration simply means that you go back after you've reached this step, and you go back to the prototyping process. So after you've researched the problem space and the solution space, you build something. That's what prototyping means. You start building something that's not a final product. You go and test it and evaluate it. So you assess based on the data, how well does it work to solve the problem. And iteration just means you go back to the prototyping step and redesign something and rebuild something, retest it, get some more data, reevaluate it, and then tell others about your results and go back to researching. So that is the engineering design process that I'm going to have you all use as my advanced students throughout this semester. We're going to dive a little bit deeper today into researching because, again, you're about to start your project soon, and I want you to be able to understand how to begin approaching your topic using this process. So researching is broken down into the problem space and solution space because it's important not just to think about the problem or not just to think about the possible solutions to the problem, but also to think about the problem itself. So let's dive in. When researching the problem space, which the problem space, I say it this way because it is not just a single problem that you were trying to solve, but all of the kind of related ideas and associated problems with the one that is being asked of you. So some questions to ask yourself or for your team to ask themselves are: what is the need? What is the problem? What are the mechanisms of the problem? And what other symptoms is the problem causing? So, what is the need? If you ask people what their problem is or what they want help with, they will tell you the symptoms of a problem. If you ask somebody what is wrong, they'll say, hey, I have a runny nose or I have a cough. Or if you ask an astronaut, what do you need help with? They're going to say, I'm sleep deprived, I'm tired. And we would describe these just like we would in the medical industry as symptoms. In business, we refer to these as pain points. And these symptoms or pain points are what people really care about you solving. But usually they're not the problem itself. You have a runny nose because something else is going on. You might have a broken bone because you were playing a sport or doing something else that actually caused you to have that symptom of a broken bone. So when you're identifying the need, you're identifying what these symptoms are, what these pain points are, and that way you are able to provide the solution that is being asked of you. However, you do want to go a little bit deeper, and that's why the next question is, what is the actual underlying problem? Now that we know the need, what is going on behind the problem? And you can usually get to this. I identify two methods here. So the 5 whys, which is a method of root cause analysis. And so if you typically have a problem and you ask yourself or you ask your team or the customer client, okay, so you have this problem. Why do you have this problem? Okay, why do you have that problem? And you go back 5 times and it is said that you usually get to what is known as the root cause. And keep in mind that usually there are multiple problems contributing to the same symptoms. So when we're talking about astronauts being fatigued or sleep deprived, there's usually multiple underlying reasons or underlying problems behind that individual symptom. The next question that you want to ask is, what are the mechanisms of the problem? And what I mean here is, how exactly does the problem create the need? So there's this underlying cause behind what the actual pain point is, and your job in asking and doing research on the mechanisms of the problem is to understand exactly how whatever is causing the problem is creating the symptom. Next, what other symptoms is the problem causing? And it's interesting to look at because, for example, the astronaut's workload is one of the underlying problems behind their eventual sleep deprivation and fatigue. So their lack of sleep and their fatigue. And the mechanisms, there are specific mechanisms of how being overworked actually causes you to lose sleep or for you to be tired. There are certain ways that this happens in the brain and physiologically, so in the body. But that initial symptom of too much work that causes a lack of sleep or that causes somebody to be tired, like an astronaut, there are actually other things that too much work may cause, like stress, which can have other problems on the body and in the mind. And so, a single solution that if you were to solve the underlying problem of too much workload, for example, then you would solve multiple symptoms and not just sleep deprivation or fatigue, but you would solve other things such as stress, as an example. And so, when you have a single solution that solves problems with multiple symptoms, this can be more efficient or even cost effective. And so, in business terms, when you're solving multiple pain points, then that allows you to make more money. And as a researcher or a future STEM professional that can solve multiple problems with the same solution, then you will also be more likely to have better career opportunities for yourself. Researching the solution space comes next. Now that you understand everything about the problem. So not only what is the need that is being asked of you, the underlying problem, the mechanisms, and the symptoms. When you're researching the solution space, it's also important to kind of go through a formal method. So typically, students will stop at this step. So brainstorming. What can we think of for possible solutions to the problem? And then typically they'll just pick the coolest thing, like, oh, there are asteroids that are coming to Earth, so let's totally shoot them down with laser guns, because that sounds awesome, and that is awesome. But it is very important to go past just this initial brainstorming stage before you start developing, or you're going to end up wasting a lot of time, and you're going to cause yourself so much more work if you don't go beyond the initial brainstorming step. So after you've brainstormed some possible solutions, it's important to actually do some research on the solution and what all the possible solutions could be. So the first step is to look at the past. So what have experts done before? And of those attempts that experts have done in the past to solve solutions, what has worked and what didn't work. And there are lots of resources that you can use to find this information. I'm going to teach you how to use some of them this semester, such as Google Scholar or through your school library. And so you look at what worked versus what didn't work, and then you can do something called an analysis of similar systems, which is simply you look at the products or you look at the actual solutions that have been developed by these experts in the past to solve this problem, and you compare them. You do what's in business called a cost benefit analysis, and you just simply look at the pros versus the cons of using those solutions. After you've looked at the past and you've looked at what experts have done before, what worked and didn't work, and you've compared those solutions against each other, which is really what the AOSS represents, then you can start looking at what is going on right now. So there may not be an actual solution that is fully developed, but people maybe are still in the prototyping stage at universities or maybe other student teams in middle school or high school. So what are these experts currently working on? What are people at colleges and universities currently working on? They may not have a full solution, but what is their thinking? How are they approaching this problem? And what are they doing that is within our budget or our level of expertise? So what do we have money for? Because especially as middle school students, we're working on a budget of, free. What can we do for free? We don't have millions of dollars to throw at solving a problem, and sometimes we have our areas that we are really good in. We have certain students will have certain skills that maybe other people don't have, but in sixth grade, you haven't been spending an entire decade learning about a problem. So what can we do that we know how to do and that we have money for is the next step in researching the solution space. And then it's important to look at the future. So what future technologies are out there or that are coming up, and what could they enable us to do? This does require a little bit of understanding about what technologies are going to be coming out in the future. And so when you're learning about this, try to just look at what technologies are going to be coming out in the next 10 years. This depends